Okay, let us continue previous video. So now we will discuss on that stability. What is the stability? Stability of an instrument is defined as to retain its performance throughout its specified storage of life, and operating life is called stability. Once again, I will tell that stability is defined as to retain its performance throughout the specified storage. Say that, so suppose one instrument we are going to using such a long time, say that for a period of 5 years, the instrument we are going to using that instrument. So what is going to be happening? The performance should not be low. So it should not be low, means suppose that one instrument readings we are going to taking, it is going to giving 10 rpm. So next year also the instrument should give the test 10 rpm reading only. Another, that is called the instrument is going to be giving stability. Whenever we are going to the ability of the instrument to retain its 100% performance throughout the specified storage, means suppose the specified storage say that 5 years, means that life we are going to giving 5 years. 5 years the instrument should give that performance throughout that entire 5 years. That is called as stability. Okay, next we will see that range or span. So the range and span we are going to define as the minimum and maximum values of a quantity. The minimum and maximum values of a quantity. The instrument is to measure which instrument is measured range or span. Suppose that the minimum and maximum values of a quantity. Suppose what is that minimum span of a bar? Say that 10 meters. So that 10 meters we are going to calling as, whenever we are going to measuring that length of the bar is 10 meters, same range should be there after 5 years. There should not be any change. That is called as range or span. Okay, by seeing of this figure we can say that range or span clearly I shown over there. See that this is the span, ideal transformer functional curve inner side. Specified accuracy limits should be there. These limits should not be crossed over there. Real transfer function should be curve. This is the blue line is the real transformer curve. This is the span. Say that the span is 10 years. 10 years it should be there. Whatever internal changes should be there, we don't want. But that span or range should not be changed. That is called as range or sometimes the accuracy will be there, specified items or range, span of the will be there. Some accuracy will be there. Accuracy is going to be changed. That we are not going to talking about that accuracy. Here we are going to talking about that range only we are going to talking about. Okay. Next we will see that bias. What is that bias? The bias is the constant error. Only constant error. This will exist. The full range of measurement of an instrument is called as bias. So once again I am going to repeating, the constant error which exists over the full range of measurements of an instrument is called as bias. Suppose say that tachometer I am going to, or you take as pyrometer or anything glass tube manometer. The manometer should be show that entire specific period same error. It should not be changed. That is called as bias. That is called as bias. So this zero error is an example of bias which can be removed by that calibration purpose. Which can be removed by that calibration purpose. So next we will see that tolerance. What is that tolerance? Tolerance is the maximum allowable error that can be specified in terms of certain values while the measure is called tolerance. So tolerance will be there. Suppose plus or minus will be there. Suppose we are going to measuring that one job, it is 10 mm should be there. So tolerance will be there either 10.12 or 9.99. So that suppose you take job length is 10 mm. So that tolerance we can give as plus is 10.12 or minus 1 is 1.98, 1.99 like that. That's tolerance should be there. In that tolerance, the job can be fit in that shaft. Okay, that is called as a tolerance. So it generally it will be specifies as maximum allowable deviation when that manufacturer's device from the mentioned value. So manufacturer itself he will mention that what is that tolerance. We can see that what is that next hysteresis. Hysteresis is the phenomena, we are going to phenomena different output effects while loading and unloading. So it is hysteresis is defined as that output effects will be there when that loading will loading and unloading. So output, suppose you can put it as say that we are going to keeping in IC engine 10 kg load. So and we are going to unloading 9 kg, 8 kg, 7 kg, 8 kg. Like that, whenever these different output effects will be there, whenever loading and unloading, that is called as hysteresis. So different outputs, generally it will come whenever load is reduces, output will affect. So that is called as hysteresis. Generally hysteresis takes place energy put into the stressed parts, and while loading and recoverable one unloading. Yes, whenever we are going to putting load, the stress will be the more. Whenever we are going to removing that load, unload will be there, the stress will be the low. Means we are going to removing. So when this instrument generally varied from 0 to full scale of the full scale, and we can say that input decreased from that full scale value to the 0. So output will be the varies. So generally this output will be the particular, while increasing and decreasing the varies of the internal friction. So then it is also called as hysteresis. Main this hysteresis is defined as phenomena that which dissipates, means different output effects while loading and unloading. Output will be the affected will be there. Different outputs will come, so that output will be the effect to that any instrument, you say that any equipment. So that is called as when loading and unloading of the job, that is called as hysteresis. So next we will see that how that hysteresis will be there, loading and unloading will be there. So two graphs I am going to showing. Whenever we are going to loading, the hysteresis will be there. Whenever we are going to reducing the load, see that how that effect will be there, output versus input. Okay, you can clearly we can observe this output and input. Okay, this is with the help of this diagrams also we can understand that we can understand that how that output will affect in hysteresis. So now till now we discussed that static characteristics. Now we will see that dynamic characteristics of a measurement. So generally these measurements will respond to that instantaneous changes. Means time to time it will vary, instantaneously it will be vary that. So that the response is slow, or it will affect on that mass, thermal capacitance, electrical capacitance, inductance, and other things it will be there. Sometimes even the instrument has to wait for the some time till that response occurs. So that is also one of the cause in the dynamic characteristics. So the behavior such means the dynamic means time to time vary. When that time to time vary, the dynamic characteristic will come, and it will affect to that so much of so many things, like as a mass you can say that thermal variation will be there, capacitance, electrical capacitance, inductance, so much of extra will be there. So that thing we will discuss. So generally this type of instrument normally we are going to using that fluctuate with the time. means fluctuating with the time. So the behavior of such system, whereas the input varies from that instant to instant, the output also varies. So that instant is called as a dynamic response. Means instantly the characteristic is going to be responded, means the output also varies, then that instrument is called as a dynamic response. Means instant to instant, means suppose the time is 4:30, 4:31 again one more response, 4:32 is one more response, like that the system is going to be responding dynamically. That response is called as a dynamic response system. So the dynamic characteristics of the system is of the measurement system is speed response, fidelity, lag, dynamic error. So that we will discuss speed response. First one, the speed response is generally it is defined as an instrument response changes in the measured quantity. So measured quantity, whenever we are going to measuring that quantity, it is going to be changing according to that speed. That velocity, we can say that response is called as speed response. So generally speed responses will show that active and fast systems. So generally speed, we can take that speed, we can measure that speed, that systems we can take as a example. Next one, fidelity. This fidelity is a degree of the measuring instrument or measuring in a system that can be capable of reproducing the changes in that input without any dynamic error. There should not be any dynamic error, but it should be reproducing the changes. If the dynamic error will be there, that is not called as a fidelity. When that dynamic, when that fidelity is called as reproducing the changes in the input without any dynamic error, that is called as fidelity. Okay, next next video we can discuss remaining characteristics. Thank you.